All right, let's wrap this up. We're gonna finish out the rest of the review here. Again, feel free to fast forward if you know what you're doing on some of these. Find the sum of the interior angles of an octagon. This would be a really good formula to write on your cheat sheet, right? This is the sum of the interior angles of a polygon. Okay, and minus 2 times 180. So if we're talking about an octagon, that's going to be 8 minus 2 times 180. Okay, and if you plug that in, that's 6 times 180, or 1,080 degrees. All right, next one. Two sides of a triangle have lengths of 14 and 23. What is the range of possible values for the third side? Remember, this is the one where we called one of the sides x, and we knew that x plus 14 has to be greater than 23. X plus 23 has to be greater than 14, and 14 plus 23 has to be greater than x. So you could solve those, okay? Take away 14, you get x is greater than 9. Take away 23, you get x is greater than negative 9. And then combine those, 37 is greater than x. The negative one will always be the one that goes away. So you can ditch this, and that would mean that our range is between 9 and 37. Okay, the other thing that we said you could do is you could just subtract these two. So 23 minus 14 is 9. Add them, 14 plus 23 is 37, and that will be your low and high end. So this is your range. All right, this one says write the equation of a line in point slope form. If I were you, I would write point slope form on your cheat sheet. Okay, point slope form is y minus y1 equals m times x minus x1. So this is going to be, find the slope first, x1, y1, x2, y2. If you haven't already written the slope formula, write that one down too. M equals y2 minus y1 over x2 minus x1. Okay, so that'll be for the slope of a line. Okay, so we're going to set this up. Find the slope first. So m equals y2 minus y1. So 6 minus 4 over x2, negative 2, minus x1, which is 8. So 6 minus 4 is 2. Negative 2 minus 8 is a negative 10. So we get a negative 1/5. Okay, that's your m, that's your slope. And then you pick one of the points, and it doesn't matter which one. I would probably just pick this first one, and you plug that into this form. Okay, point slope form. So it's going to be y minus the y value, which is 4, equals the slope, negative 1/5, times x minus the x value, which is 8. So this is a good answer. Or if you use the other point, it would be y minus 6 equals negative 1/5 times x minus a negative 2 is x plus 2. So this would also be a good answer. Okay. All right, number 21 says complete the proof. It says C is the midpoint of both of these segments. So if C is a midpoint, okay, first of all, let's start where we always start. The given goes here, and that is our given information. But if C is the midpoint, we're actually going to say two things here. We're going to say AC is congruent to CD. And we're going to say EC is congruent to CB. Okay, so that's definition of a midpoint. Okay, And then take a look. We're trying to prove the triangle's congruent. So first of all, we know that's what goes here, right? Whatever you're trying to prove is your last step. And whenever we prove triangles congruent, it is SSS, SAS, ASA, AAS, or HL. Maybe you want to write that somewhere in your cheat sheet. So look at what we know. We have two sides. We either need to know the third side or we need to know the included angle. Well, if you look, those two angles are vertical angles. So we're going to use vertical angles to prove this. That would be angle ACB congruent to angle ECD because of vertical angles. So now the triangles are congruent by side, included angle, and side. So SAS. Okay. All right. Then they give you this picture and it says name these three segments as one of the points of concurrency that we talked about. So AQ, okay, it goes through a vertex and it's perpendicular. Is that perpendicular bisector, angle bisector, median, or altitude? When it's perpendicular, it's going to be one of these two, an altitude or a perpendicular bisector. This one, because it goes through a vertex, it's not bisecting the opposite side here. It's obviously not in the middle. Altitudes don't need to be in the middle. So this one is an altitude. Okay. Then we look at BR. BR is right here. And if you look at the markings, these angles are marked congruent. Congruent angles come because of an angle bisector. Okay, and then CP, notice that CP goes from a vertex, and then the markings show that it's a midpoint of the opposite side. So that's a median. Okay, if it is a perpendicular bisector, which is the only one we didn't see here, we didn't draw in, that would be a bisector, right? So like point P, but perpendicular. So this has to be a 90-degree angle if it's going to be a perpendicular bisector. All right, 23. It says this is a parallelogram. Solve for S and find the value of each angle. So in order to solve for S, you got to think about what we know about these two angles. Those are consecutive angles in a parallelogram, which means those are same side interiors, so they are supplementary. So we're going to say 8S plus 5 plus 3S plus 10 equals 180. So 8S plus 3S is 11S. 5 plus 10 is 15. Okay, so we're going to take away the 15. And then we're going to divide. So 165 divided by 11 gives you 15. Okay, so that's the first step, but then it says to find the measure of each angle. So if we plug that in, okay, 3 times 15 plus 10, that's a 55-degree angle. If you do it up here, 8 times 15 plus 5, or you could just say what is supplementary to 55. Either way, this comes out to 125 degrees. Okay. All right, 24. What is the intersection of these two segments? So AX is here, CM is here. You're looking for where do they meet? They meet at this point, which is point N. Okay. Then they're saying, where does plane V? So plane V is this. Right, the whole pink plane is plane V. Where does that meet CM? And if you notice, CM is a solid line. There's no dotted there, so that's not poking through the plane. It is lying on the plane. So the intersection, let me erase this to show you how they named it. it says segment CM. Okay, where does that intersect? Uh-oh. Sorry, things wigged out a little bit. Segment CM would be the overlap, just that segment itself. So you would say segment CM. Okay, then it says, where does RN? So here's RN, and notice right here it becomes a dotted line. That means it's poking through the plane. Okay, so if you think about a piece of paper laying flat and a pen going like vertically through, there's only one point where it hits the paper as it goes through the paper, right? That would be at the point, which is point N. Okay. All right, 25, find the value of X and the measure of each angle. So you have 3 angles and it's a triangle. The sum of the angles of a triangle is always 180. So X plus 2 plus 6X plus 10 equals 180. So that's 8X. 2 plus 10 is 12 equals 180. So take away the 12 and you get 8X equals 168. And then divide by 8. So X is 21. Okay, so that's the value of X. And then the measure of each angle, if this is X, that angle is 21 degrees. 21 plus 2 makes this one 23 degrees. And then you can either plug the 21 in for this last one or make it add up to 180. Either way, that last angle is going to come out to 136 degrees. Okay. All right, 26. This one you have 7y plus 3 for GH. HI is 3y minus 5. The whole thing is 9y plus 7, okay? So we know the 2 parts have to equal the whole. So what you're gonna do here is add the 2 parts together, 7y plus 3y minus 5, and that will be equal to 9y plus 7. So 7y plus 3y, that's 10y. 3 minus 5 is a negative 2. So we're going to take away 9y, and we're going to add 2. So y equals 9, and that's all they asked you to do here. If they asked you to find the length of each one, then you would plug it in, right? Plug it in here, plug it in here, plug it in there, and that would give you all your different lengths. All right, 27. It says one hexagon is congruent to another. So you got to match up the corresponding parts. So if you look, segment DE, that's the 4th and 5th letter. So 1, 2, 3, 4, 5 would be congruent to segment XY. And then this one says angle VWX, okay? VWX is this angle. So really what they're saying is it's that middle letter, right? This is the vertex. So you could technically just say it is angle C, or you could say BCD, or you could say DCB. As long as the C is the angle you're talking about, then that's what would be congruent. All right, 28. This one is telling us that the lines you're seeing are parallel. A is parallel to B, and C is parallel to D. Okay, so then it says 2 and 10 are what kind of angles? And if you look here, from the vertex, it's the top right with the top right. They are in corresponding locations. So those are corresponding. Remember what you know about corresponding angles? Corresponding angles are congruent, right? Angle 3 and what angle are alternate interior? So here's angle 3, okay? To be alternate interior, it's going to have to be using A and B as our parallel lines because it's on the exterior of C and D. So an alternate interior there would be, if this is our transversal, angle 7. Okay. Then it says angle 9 and angle 8 are what type of angles? Those are same side interior angles. Oops. Okay, so those are same side interior angles. Remember, those ones are supplementary. So together they would add up to 180. Letter D, which angle could you show is congruent to angle 11 to prove A parallel to B? So if we're trying to say these two lines would be parallel, and we need something to be congruent to angle 11, okay? The transversal that we want to use then is D, and what would have to be congruent to 11 would be angle 9, because those would be corresponding angles. All right, and then it says, what relationship between 6 and 11 shows C is parallel to D? Let me erase all the scribbles. So 6 and 11, we have, oh, come on. I hope you got that. Sorry, my iPad is not being friendly. So 6 and 11, okay, here's 6, here's 11. To show these two are parallel, those are same side interiors. So what relationship do you need? They need to be supplementary, meaning they need to add up to 180 degrees in order for those lines to be parallel. Okay. All right, moving on. 29. It says the measure of angle ABC is 100. So this angle is 100 degrees. Solve for x. So that means the sum of these two should equal the 100. So we're going to say x plus 3 plus 2x plus 4 equals 100. So x plus 2x is 3x. 3 plus 4 is 7. So take away the 7, and you get 3x equals 93. Divide by 3. So x is going to be 31. And then it says, what is the measure of angle ABD? So from A to B to D. That's that angle, okay? If x is 31, that is x plus 3. So we're going to go 31 plus 3 is 34 degrees for the measure of ABD. Okay. All right, number 30. What is the pattern and what are the next two terms? So if you're looking here, to get from -6 to 12, and then 12 to -24, and -24 to 48, we are multiplying by a -2 each time. Maybe it's better to write it like that. So the pattern is times -2, or you can say times -2 if you feel better about that. So then the next two terms, 48 times -2 would be a -96. So that's your next term. And then -96 times -2 is going to be a positive 192. Okay, so here are your next two terms. However you want to write times -2 or times -2, however you can get that point across. Okay. 31. These are what we call alternate, opposite sides, right? And then exterior angles. and alternate exteriors are congruent, maybe you want to make a chart. Same side interior angles have to equal 180, but alternate interiors, alternate exteriors, and corresponding angles, okay? All three of these are all congruent to each other. So these are alternate exteriors, so we're gonna say 4x minus 4 equals 120, and then solve. So x is 31. And that's all you had to do on that one. Okay, 32 and 33, these are the last two. Use a compass and straight edge to find the circumcenter, and then compass and straight edge to construct the angle bisector. You're gonna do this on paper, okay? But I can't walk you through it on paper. So I'm just gonna show you how to do this. I'm gonna remind you on this one. This is the one where if you go more than halfway on any of your sides, pick the longest side, go more than halfway, and then you actually can, ooh, sorry, I'm trying to put my Apple Pencil into a compass here. Let's see if I can make this work. Well, maybe. Here we go. This is going to be interesting. I'm going to try not to poke a hole in my screen with the pointy part. Okay, so if you go more than halfway on any given side, so I'm on point E right now, let's say, and I go more than halfway, I'm going to draw, ooh, this is not going to go well. It's sliding all over. Yeah, that's not going to work. Okay, forget it. I will just explain and freehand because that'll be better. So if I put my point on E and I draw a big arc, it will look something like this maybe, okay? Then I'm gonna put my point on D and I'm gonna draw another big arc. So coming over here, ooh, that's really bad. Try again. Nope, that's horrible. Okay, well, we're gonna just go something like that. It's not great, guys. This is not great. Ask your neighbors though. They can help you with this too. Or maybe I already helped you yesterday in class. So then from F, you're gonna do the same thing. Ugh, it's terrible. Okay, what you're trying to do is get a point and then follow that around to where it meets with the other side, okay? So there's 2 points that you're gonna draw a straight line through. Then you're gonna pick a point out here and follow that around to where they meet and draw that through. And then you're gonna pick the last point and follow that around to where they meet up and draw that line in, okay? And what happens is all three of those should meet at one point and that will be your circumcenter, okay? So that's perpendicular bisectors. Angle bisectors is the one where you put a point here, you draw an arc, okay? And then from those 2 points of intersection, so from right here and right here, you would take your compass and you would put from this top one, if my point is there, I'm gonna put a little mark like this. And then from this one, I'm gonna put a little mark like this. And then where it makes that X, you draw the line in, and that would make this angle congruent to that angle, okay? You won't have to do any other constructing other than potentially perpendicular bisectors or angle bisectors on the whole final. So if you know how to do perpendicular bisectors or you know how to do angle bisectors, you'll be just fine, okay? It's just a matter of how many will you end up doing. So that is it. Remember, there's a study session on Monday from 1:15 to 2:15, okay? Happy studying.